And it's actually kind of fun to watch somebody else do something, and there can be boring pauses while stuff is happening or while people are figuring out what to do, or oops, I did something wrong, figuring it out, how do I fix it. But it's a really cool thing to do, and it's fun to watch. So good job with that.
Thank you. I actually blame Matt. Matt put that terrible idea in my head. So, oh, thank you. Can everybody hear me, or do I need to? Okay. Okay.
Without the microphone and then see if they can hear you.
Pardon?
Try it without the microphone and see if they can hear you.
Oh, okay. But since we're doing the live stream, then even if I don't want the microphone, I got to have it. Plus, I have cedar allergies. So tonight's presentation, creating and publishing a Python package. I didn't really want to get into like all the messy details. I'm going to try and glide through this as quick as I can. Originally, when Danny and I were talking, the talk was going to be something like creating a Python package the wrong way. And then along the way, actually kind of turned into doing it the right way. And so this is the end result. But then this is actually based on kind of trial and error in putting out my first Python package. So even tonight, even though I've read these, all the slides a million times over, trying to make sure there's no errors. If somebody does see an error, then please reach out and contact me, mostly for my own edification. And then also at the very end, we can do some Q&A, but also if y'all want, I can get your email addresses and then kind of carry this on a little further for those that actually want to take this first spin trying to create a package. So, topics covered tonight. Excuse me. Topics covered tonight is going to be structure of a package, importing and using a module from a package, fundamentals of development and documentation, version control and feature branches, and continuous integration, continuous delivery workflow with GitLab. So this is the Python community, and I tried to break it down to an analogy that would make sense. Much thanks to my brother and my wife for setting me on a better path. Originally, the analogy was with sushi. And so I kind of view the Python community like an airport with a lot of people with a lot of suitcases. And then these are Python packages, suitcases with contents inside. Inside of the packages are modules. So you've got your toothbrush, your deodorant, your soap, your socks, everything like that, all performing different functions. The Python package index, PyPy, as y'all heard in the lady that was giving the talk right before me, is kind of the general area for distribution for grabbing packages. So it's, if we're going to stick with this luggage analogy, then it's like the conveyor belt at an airport where, in theory, you can just grab suitcases off and inside as modules. If you try that in real life, you'll probably go to jail, so don't do that. Python programs. Again, we're back to the suitcases, and Python programs, a lot of times, there are a lot of great modules that exist that keep you from having to rewrite code or reinvent the wheel. And so, I'm sorry, it's cedar. So it's something that Python programs, in a lot of cases, you're able to take pre-existing modules and stack them together to create entirely new programs, as well as your actual code, then gluing it together. Package overview. Module is a set of reusable definitions and statements. Package is a collection of modules. You should publish a package if you believe you've created something usable, which other developers may find interest in. And then the PyPy, Python Package Index, is where the packages are published and located at pypy.org. Installing a package. So you've heard pip. The most common way is using pip, which is the recursive acronym for pip installs packages. Without additional arguments, pip downloads from PyPy with the syntax, so it would be pip install and then whatever package you're wanting to grab. Pip can also use other sources such as Git repositories, websites, and even local file paths. To add packages for development, you would use requirements.txt. To add packages for your own packages requirements is where you would use setup.py. So you will see a lot of people tend to merge requirements.txt and setup.py together. and it's kind of a religious debate. Some people are on one side saying it's the same, other people are on the other side saying it's not the same. I am on the side saying it's not the same. So requirements.txt is for yourself locally. Setup.py would be the bare essentials for somebody to use the package that you've made. The package structure, this is the hierarchy. It's defined by folders here on the left side where you can see Suitcase, still running with that analogy, which are typically based on categorical purpose. So inside of, I'm sorry, bear with me on Cedar. On this Suitcase analogy, we've got the top directories, we've got clothing, we've got electrical, we've got toiletries. And then in some cases, you'll see it nested down, such as clothing to shoes and undergarments, while as electrical does not have any submodules. Toiletries has grooming as well as deodorant and soap. And then inside of soap is where you could sit there and have, say, shampoo and then bar soap and toothpaste, for example. Each of the Python files within a folder constitutes a module and can contain variables, functions, and classes. Python has a lot of magic variables behind the scenes. So in this case, there's one that's called all, and you can import modules at the same directory level. I'm actually did not have enough space to try and cram all that in, but to kind of guide you through where all is useful. If we had electrical, or let's actually go with grooming since we have init.py instead of grooming. In the grooming folder with init.py, we'd be able to manipulate the all magic variable, which then would let us grab everything inside of it, such as haircut and shaving. And then we wouldn't have to do recursive imports. So there's several ways that you can take it with the all magic variable. Prior to Python 3.3, latest and greatest being 3.8, you had to put an init.py file in each directory to sit there and indicate that it was a module. And then that requirement was removed in Python 3.3. On to importing and using a module from a package. Importing and aliasing a module from the package. So again, back to the Suitcase. We've got Suitcase right there. If you follow the arrows, we've got clothing, and then we've got shoes. And then we are importing exercise, and we are actually aliasing exercise as my shoes. So my shoes is going to be the object that we're working with. And then for my shoes, we are going to put on my shoes, and we are going to tie my shoes, in which case those functions are defined. So first one, as you can see, is for putting shoes on your feet. Second is for tying your shoes. The results from running that, I have put my shoes on my feet. I have tied my shoes. So far, questions or continue? Okay. So when is init.py used? PEP, PEP 420, the implicit namespace packages, has a little more definition on this. And this is an example of actually operating inside of an init.py file. So we are sitting there importing and haircut and shaving, and we've made a function called prep for meeting. So prep for meeting, when we run that, is then what's going to give us a bowl haircut and give us a nice clean shave all the way to our bare skin. Fundamentals of development and documentation. Building a package skeleton. So briefly in the beginning, I had flashed a card of if you've got your laptop around and you want to try it, you can actually run these commands that are here on the screen, and you would be able to walk out of this room with a package skeleton that then you could operate on. So PyEnv is a great tool. If you've never used it, then definitely check it out. It stands for Python Environment, and it lets you change between a multitude of Python versions. And it's something that you can even isolate when you're making a project using PyEnv. You're able to even isolate particular folders down to particular versions of Python, including virtual environments. So in this case of running these commands, we would do pyenv install 3.8.0. That would grab the latest and greatest Python. Then from there, the second line is creating a virtual environment from 3.8.0 that's called Suitcase. Beyond that, we are making our top directory, capital Suitcase, and then inside of that, we're making two directories, lowercase Suitcase and docs. And what you'll see with a lot of Python packages, my package included, is you'll see, for example, on mine that's available on PyPy, you'll see polycephaly, capital P, and then inside of it is like setup.py, there's readme.md, there's then lowercase polycephaly. So the directory inside of there that's lowercase polycephaly is actually the Python module. Then we will go in, we'll change directories to Suitcase with the capital S. We're going to create our Git repository. And then this is what I was talking about with Python environment, where we will then set our virtual environment from number 2 right there down here as our local Python environment. So from this point forward, every time that we go to our project directory of capital S Suitcase is then where it will pull our Python virtual environment that we also call Suitcase. From there, we'll make GitLab continuous integration, PyTest, requirements.txt, setup.py, readme.md, and then inside of the Python module is where we also create init.py and log.py. And so these commands right here, if you run them later, I had seen a couple of people taking pictures, and if you run these commands later, like I said, you will have just a skeleton package that you can actually work on and start playing with. Personal preference of mine is I don't like to spend a whole lot of time messing around with environment variables, especially when I'm changing between so many projects. And so in this case, I create a permanent solution, which is making a symbolic link to my package that I'm working on. So you see it as pwd Suitcase, and then that's created inside of this particular virtual environment's site packages. From this point forward, if I close my shell, restart my machine, whatever happens, every time I come back to cd Suitcase right there, number 4, then my package will always be available to me without me having to do anything extra. And then just to confirm, you can view the directory and see what your site packages are. And since it can be different on computers, there's not a fixed path, so that's actually why we're running a subshell, and we are querying Python to ask where are the site packages located, and going after the first result, which usually there's just one result. So already explained it, but just to reiterate it on why I have a symbolic link inside of the packages. And these are the results. So on the left side is the site packages of our virtual environment. There you see the symbolic link, Suitcase, which is then pointing to the right side. So I'm inside of my project directory, and then that symbolic link goes straight to the Python package, lowercase Suitcase. And as I said, in the capital S Suitcase, that's where you've got docs, PyTest, README, requirements, setup, and you can just go on down the list as you continue to build your own project out. Adding packages to our own development environment. As I had said earlier about requirements.txt, this is for your development environment, such as Sphinx for generating documentation. So you can install your entire development environment by running pip install -r requirements.txt. In this case, I work with, all the time, I work with the logbook on a daily basis. But this is an example also with some of the common ones that I always use: logbook, PyTest, Sphinx, Twine, and Wheel. And I know Jacob had asked actually about if I was going to get into wheels and eggs and all the past iterations of how Python was handling packaging. And the short answer is no, I'm not. But it's taken quite a while for Python to get up to what I think are really great results. So being able to, where we've got it these days, where it's so easy to create a package like this, it's very easy to get spoiled and forget about the hard work that it took by tons of people involved with the Python project for it to be this easy. PyTest, for, I guess, kind of poll on the audience, who here has read the Google SRE book? Only 2 people in the room. Okay. Me and my former coworker. Okay, so the Google SRE book, it's a great book. You should definitely read it. It is a book that's by several of Google's engineers on how they create such a reliable service. So that book really hammers home the push on green mentality. And so covering the topic matter tonight is actually what I'm also kind of pushing in that direction of push on green. So PyTest is a very big part of that. However, there are also some other cases of how things can go wrong, and I will also cover that, and how using CI/CD, then we're only going for push on green that the Google book talks about. For those not familiar with Sphinx, Sphinx actually lets you write your documentation inside of your source code. So instead of trying to maintain your source code and then trying to maintain a wiki or any other number of ways of trying to maintain your documentation, using Sphinx, you're actually able to write your documentation in your source code. And then there's 2 common formats. There's NumPy and there's Google. My personal preference is NumPy. I think it's a lot easier to read for a human. It's kind of like comparing JSON or even YAML to XML. And so the NumPy formatting, even inside of your source code, you can put in sections and then cover those sections, cover your variable types, your function returns. It's everything for every which way for anybody that's coming after you, that's reading your code, for how they can follow it from a documentation perspective, not a source code perspective. And then Twine and Wheel, just to keep it very, very, very simple, we're just going to leave it at it's used for publishing your package to PyPy. So, wrapping up the package skeleton, it's down to Sphinx Quick Start Docs. It's as simple as that for setting the docs directory as your source for how the documentation is compiled. It will ask you when you run this command, it's going to ask you if you want to separate your source and your build directories. Again, my personal preference is that I like to separate my source and my build directories. That way, if I ever get desperate, I can just nuke the build directory and rebuild from scratch without having to worry about messing up any of my source documentation or having to regenerate my source documentation with Sphinx Quick Start. GitLab CI YAML, that's one that lets you put in all your settings for continuous integration and continuous delivery. I'm so sorry. Continuous integration, continuous delivery via GitLab. And there's just not enough space in these slides to put all of the code that it would take to show it. That's why I'm just unfortunately having to cover the highlights of which files you should be paying attention to. Docs source conf.py. This is where you would load in Napoleon, which is a plugin for Sphinx that parses your source code. And again, like I said, I prefer NumPy style over the alternative Google style. PyTest.ini is where you're putting in very basic parameters for how PyTest will run your unit tests. Setup.py is for you can actually add Sphinx building as well as centralize your version number and your required packages. So instead of having to run separate commands, you would actually be able to use setup.py and then give it an argument of build Sphinx, and now you've got kind of a Swiss Army knife that runs your entire package. For centralizing version numbers, again, this is a religious debate. There's a lot of people that have a lot of different opinions on how should a version number for your package be specified. I'm of the side that says put your version number inside of setup.py. There's even separate modules on, or I'm sorry, separate packages on PyPy that are geared entirely for covering a version number. My personal opinion is that that's a lot of extra effort just to clearly spell out your version number. So again, that's why I like to just dump it in setup.py and let setup.py be what answers all of the other questions relating to my package. Those required packages that I had mentioned earlier and the difference between requirements.txt and setup.py. Again, this is the bare minimum that a third party would need for your package to actually work, as compared to requirements.txt, which is where you're loading in Sphinx and all of these other packages for what we'll get to later in the CI/CD side of things. So we add all of these files to our Git repository, git add.period, since we're still inside of our capital S suitcase directory. Then we make a commit, and we call it initial skeleton as our message. And each time that you add source code files, you will use this command to rebuild source docs. Again, it's back to Sphinx API doc, and then that's where you're specifying the path to your documentation, as well as to your Python package as the second argument. Save your documentation source files with git add and git commit, just like above. And we are all the way to version control and feature branches. Your master branch is the be all and end all. Please, 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 always work on a branch. When you're ready, merge that branch to master. Not everybody has fast internet. There's actually been times where I'm overseas and trying to clone what here with pretty good internet in the United States overseas. I've actually had to do clones on remote servers and then run rsync with bash scripting for 2 to 3 days just to get a copy of that all the way to my computer. And so if you're contaminating your master branch with all of your commit messages, then that's also something, unless somebody that's very familiar with Git and just cherry picking from that one specific, your last commit, they're going to be stuck downloading all of that data. So you typically want your master branch to be fairly clean, and usually even better if it's just tagged releases. Storage is cheap. Losing your data is not. Commit often. The comic on the right from XKCD is pretty much how any of my development branches look, where usually as the night wears on, it gets down to me just hitting letters on my keyboard, and my hands are typing words, and then hands. So it's something that, yes, keep all of that on your own branch. Keep that out of the master branch. So your branch will be ugly. That's okay. It's not the master. Here's an example of my development branch. And as promised, it is ugly, and it's not exactly just saying hands, but if you actually go look up this development branch right now, you will actually see all of these nonsensical messages. So a lot of times, usually when I'm too tired and I'm kind of just on autopilot, my eyes are still open, but everything else of me is asleep, I'm usually just typing in pausing point, and using source tree and plenty of other great tools, I can always catch up and see what I was doing if pausing point isn't exactly the clearest of messages. And these also, especially with source tree, lets you rewind and fast forward very easily. So on my development side, I never spend a whole lot of time worrying about what my commit messages are, mostly because I want my data to be saved. So I will make a commit, I will make a push, and I'll call it a day. If my hard drive fails on me, or my laptop gets dropped or run over or anything else, at least all of my source code is now saved remotely, so it's very easy for me to catch back up. And here we go for pushing my development branch. So I tend to push my development branch, as I mentioned. I push it, usually if I run multiple commits in one day, maybe by the end of the night, I might run 1 or 2 pushes. So if I made 10 commits during the day, and I finally do a push as I'm going to bed, then that's all of those commits that were here on my laptop. When I make that push is then where it goes to GitLab. And so this is what it looks like, where it's pushing the development branch to the remote server at GitLab. which in turn, the way that I have it set up, and I'll get into some of the minutia later, but this triggers pipelines. And so even if I'm sitting there making something that I'm 100% certain is ready to go, I'm ready to publish it to the world on PyPy, I will still always run it through the development branch first and push it, and I'm checking for errors through PyTest. And even in this case, where you see the failure happen is not even from PyTest, which I could have caught locally. This is actually when it's running one of the tests for through the sandbox side of PyPy. And so I was able to catch that. And then you'll see my subsequent push is the namespace package test failed. So that's one real world example. That was actually serendipitous. I was not trying to screw this up when I was taking these screenshots as I was making this. This was one of those things that actually bit me in the tail, and I was able to grab a screenshot and show y'all this is actually what failure looks like. But this is also what the importance of all these tests are. And as I said, not just PyTest. This is actually the testing side for going to PyPy. So this is where failure was caught ahead of time. If everything goes right, as you saw here where it's running, so when that finished, if everything goes right, all of my unit tests are passed and they're green. So we're back to push on green like I was talking about. Here we've got PyTest passed, and we've got the Python package index test also passed. So this is exactly what I'm looking for. When I get these kinds of results, like I said, even if I'm ready to go and I'm ready to push it to the world and I'm 100% certain that everything's ready, I will not do so until I see all green. And from that point, when I see all green, I'm sorry, I skipped ahead. When I see all green on the development side is then how I'll get into a subsequent screen on how I'll sit there and move the development branch over to the production side, which then also triggers not only all the tests that you've seen so far, but also triggers additional tests. So there is a heightened sense of paranoia for all of these tests, and that's because I'm always trying to keep from releasing something that if somebody out there is using my package, I don't want them to run into an error. And so by going to this extreme with all these tests, especially if they're using it in a production environment, I never want to be responsible for somebody's system messing up, and so or their software messing up. So this is how I try to alleviate that and really drive home the point about pushing on green. And we are finally almost done. We are to the CI/CD workflow with GitLab. So CI/CD configuration, part 1, basic setup. I probably should have included a screenshot of what GitLab CI YAML looks like. Really all it is 3 to 4 lines that are just includes of the files that I'm showing you. So I like to break my files up. In this case, right now I just have them as 3 files. You can also, I have a 4th one that's reserved for me for building. So in case I sit down and write some C++ code and I want to be able to merge it all together with Python, then that would be where I use the build. But I actually didn't even include a screenshot since these screenshots are actually based on the package that I released. And so that's why I as of right now, am not using even the build side. In my base, this is where I specify my Docker image for GitLab that I want to run on. I'm running on Python 3 Alpine. If you're familiar with Docker, then Alpine is pretty small. Anytime you see Alpine, or I should say almost any time that you see Alpine mixed with anything, PHP, Python, Nginx, whatever, is usually very small Docker images. And so in this case, I'm going for the smallest that I can get. I set my environment variables, I'm setting up caching, and then I'm setting up prerequisites at the system level. And so inside of this Docker image, and so this is actually, I spend a little bit extra effort to on caching. So not only am I reducing load that I'm putting on CDNs, content distribution networks, but on top of that, it also goes just a pinch faster. And so it's just a little bit, everybody has their own preference. I just don't want to, especially if I'm running test after test after test, I don't want to keep hammering on somebody's servers out there that's hosting Python packages, or in this case, Alpine packages, or anything else. So I'd rather reduce the strain that I put on their servers, which is why I spend this extra time on caching. This is actually how I put testing together, not only my unit tests, but also testing with PyPy's sandbox. And so you will see that there's 2 lines at number 3 and at 22. Number 3 is PyTest. Number 22 is the Python package index test. So PyTest is then how I do all of my unit tests, and as I continue to build out my package, I continue to add on the unit tests in the process. And then GitLab has a reserved word for stage. So this is part of how you are telling GitLab these tests need to happen before the next steps. So if these do not return an exit code of 0, if it's anything else, then that's where GitLab will purposefully fall over and stop everything else. So it will not deploy a bunk package to the world. And then after my unit tests, since that's where I'm checking for errors first, is then how I get to the Python package index test on their sandbox. Supposedly it gets cleared every now and then. My personal experience, I have yet to see that. And so it's something that's why on line 27 you'll see I'm actually set it to skip existing. For when I'm sitting here banging away on development versions, I do not consider it an error if I'm pushing version 0.5 and 0.5 is already there. However, on the production side, production release of my package, that actually would be considered an error, and then that's where this would abort. So as I said earlier, there's a lot of testing in progress. Where you will see line 16 and line 31 talking about only. These are different ways to perform your tests. This is where I'm actually performing on actions such as tags, but I'm also performing on specific branches. So I'm looking at dev pytest, I'm looking for dev pypy, I'm looking for dev ltgiv, and then again, similar story on line 32 and 33, I'm looking for dev pypy and dev ltgiv. So this is also where these tests become applicable. And then finally, this is the deployment side, assuming that we made it through everything else. If we made it through our base, and if we made it through our tests, we've finally arrived at deployment. So we've got pages, and then which is a GitLab feature for publishing HTML. And then we've got PyPy publish, which is the actual Python package index. So that on line 22 is where it begins for deploying to the real world. So anything that I push on here then becomes available to y'all publicly. So the pages on line 3, this is how I use Sphinx to generate all of the documentation based on the source code that then shows up for anybody else that's trying to use my package. And as I mentioned earlier about turning setup.py into the source, the core, the Swiss Army knife that I tend to refer to for everything. Line 9 is actually where you see how I use setup.py to build the Sphinx documentation. So instead of having to worry about 3 or 4 different scripts, I'm always trying to refer to simply setup.py. That should be the gatekeeper for this package, at least in my opinion, and that's how I set it up. From there, all of the documentation is built into docs build HTML, as we covered earlier about how I separate the source and how I separate the build from each other. So this is exactly what I was talking about, where then we're grabbing the build directory, the HTML contents, we're setting it as what is called an artifact that you see on line 14, but then that's how we sit there and say, this is the information that we now want available to the world. On the Python package index for publishing, it's pretty simple lines. It's 25, 26, and 27 go into Just re-verifying twine and wheel. Those actually, since I added earlier, in theory I could remove those. I tend to spend a lot of extra time just trying to avoid failure. So in case I change it and ever put it back here, I leave it at that. 26 is where I then compile everything together into my distribution. And then 27, line 27, is then where I actually upload that distribution and it flies off to the Python package index. And if you look at line 12 and line 29, these are the stages for deployment. So this is one of the final stages. All of the stages that I showed earlier, such as building and testing, that's where GitLab is checking for exit codes that are other than 0. And for artifacts, I save those on line 33. And you will see on line 35 that this only occurs for the release to PyPy if I have tagged my commit. So when I make a commit, even if I slip and I make a commit and I push it over to the production side, the release side, or in Git, it's called master branch. If I forgot to tag it, then this will not go public until I do. So again, like I said, I kind of take it to a paranoid extreme for checking for errors and trying to make sure that I never bork anything that could affect somebody that's actually using this package. So when I'm ready, here's how I merge from my development branch to my master branch. It's pretty straightforward process. It's git add, git commit. I finished adding my third feature, git push, where I showed earlier. Then I switch over to after line 3 on push is where I'm sitting there looking for those errors to occur on the development side. And if those are all green, then I will move forward. I will, on my laptop, git checkout master, git merge squash, dev ltgiv being the example branch, and that all of those commits, all the ugly commits that I showed y'all earlier, it squashes all of that. And then I've got git commit. I added 3 really great features, and that's the only thing that will show up on the master branch. So if there was 50 different commits and there was a lot of work here and there in between, maybe even 10 megabyte files that are then subsequently removed in further commits, that will never make it to the side by me sitting here squashing it. I then push that, and it now, like I showed y'all with the testing, it goes public. This triggers multiple pipelines, again, starting with tests. Unit tests and a PyPy test are run. If successful, the module is bundled and pushed to PyPy. So again, we're back to push on green. I cannot hammer that drum hard enough or constant enough times. I really, for anybody that works server side, you should definitely read the Google SRE book, since they also stress that as well, about the importance of push on green and having so much error checking. And that's how they make such a reliable service, and that's the wisdom. That's really, if I had to say one takeaway point from that book, that's really the takeaway point, is push on green. So always be paranoid, always check, test, and then finally let it go public. And even then, there's other topics like rolling back, but this is not DevOps or SRE, so I won't get into that tonight. Finally, the documentation is generated and published. So this is where we see in the first step how it's put together, and then in the second step, this is actually see how it's moved after the documentation has been generated, how it's moved into place. And this is what it looks like when it's published. So this is not the first screen. I actually wanted to get kind of more into what it looks like for a class with methods that's documented on the left side. But as you can see, the screen's kind of small. Let's see if I can zoom. Okay, hopefully y'all can see that. And so this is where you can see the method app exit inside of the class polycephaly.core.applications.actions.extend. Earlier, I had mentioned about the all magic variable. This is actually how I separate functionality out into multiple files, and then I glue it all together. There's just not enough time tonight to really dive into how I manipulate the all magic variable to put this all together. But the end result is what you see here. So the method, we get to find out a lot of the information, the variables that it takes, the parameters, the return type, same story for the restart method, the start method, and on and on and on. And so this is all documentation that's based entirely on source code itself. So it's very nice to be able to have something where I can spend less time documenting what I'm doing so that it's easier for anybody else that's reading any of my code. They actually have documentation that they can read and hopefully answer some of the questions that they're looking for. On the right-hand side is what it looks like on PyPy for installing the package Polycephaly. If you look at the top left, you will see 2019.11, and if you look on the right side, you'll see Polycephaly 2019.11 Alpha 5. So this is what I was talking about with consolidating version numbers together. Again, both of these are separate events that are happening for this to be here, but it's all consolidated in setup.py, and that's been the most reliable way that I've found for being able to have just a single place that I put my version number and I iterate. And then the description and everything like that you see on PyPy is actually from Markdown files that's sitting there thrown together, and I even have a YouTube video. So as Danny had mentioned earlier about he's seen some of my YouTube videos with, I guess, live coding. This is actually a little bit of that to give an example. And that's actually, I think this video, if I'm not mistaken, this is actually from when Matt and I last had coffee. And so I tend to sit there and Matt and I had coffee. We get together and discuss code a lot. And we ran out of time at lunch and coffee. So this is actually where I carried it over into this YouTube video that then ended up being a part of the PyPy itself. So in summary, we've covered what a Python package is, what it contains, how it's distributed, the 3 common ways of downloading a package, not only from PyPy, but other sources, such as Get, such as your local file source, from web servers. I've given you example code and shell commands for setting up a package skeleton. I've shown you how to develop with branches and keeping the master branch as pristine as possible. And then last but not least, using GitLab's CI/CD, performing varying levels of tests. I probably spent way too much time talking about the tests. I just have to stress the importance of it. Publishing the package in a push-on-green manner. Again, I cannot beat that drum enough times. And then finally, generating and publishing the package's documentation. And last but not least, speaking of Python packages, next time you're at a Python shell, try typing in import anti-gravity, just as you see in this comic here. And yeah, that's it. I guess we can go with questions. Thank y'all. Thank y'all for being here. Any questions? Yes, sir. Oh, wait, somebody else?
I can speak loud. So,
No, we need.
Well, there's also
for
the live stream. Yeah.
So if I understand correctly, in your testing, in your CI, you are actually publishing the package to test PyPI as
Yes.
well?
Yes.
So what kind of errors or problems is that going to catch?
So the error that you actually saw earlier was actually an error in setup.py. And that was, I was basing it on a method that I thought was still there and was not there. And so that was a case where on, I suppose, older code, on this I was working on Python 3.8, and on older versions of Python, it, I guess, would have worked. And this is a case where kind of the rug got pulled out from under me, and a method that I was trying to run did not run. And so it fell over, and that error happened on the testing side of PyPy, and that's what stopped the show for everything else.
So wouldn't that have also stopped the production upload to regular PyPI as well? Like, are there errors that are only going to get caught by test PyPI?
So in that case, that's actually where it would just stop. It would never even make it to that side. But that was also on the development branch, so that was not me even trying to go after the master branch. It's just part of the drum I was beating on test, test, test.